Hello everyone and welcome back to another video from Maths Problem Solving. Today we're going to be doing a geometry question taken from an SMC. So here's the flowchart for the question. As you can see, there are two triangles which are both right angle triangles, and one of them is a right angle isosceles one, and one of them has length 60, 30 and 90. We're basically going to work through this by working out the ratio between these two side lengths, FG and EH, and therefore being able to solve the question, which is the ratio of the area. So yeah, we'll be coming back to the flowchart towards the end. Let's just get into actually solving it. So as we mentioned earlier, one of them has side length 60, 30 and 90, and the other one is a right angle isosceles. Let's just label up this information. So we know that this is 60 degrees, therefore this would be 45 degrees, and this would be 15 degrees. Similarly, we know that this is 45 degrees, therefore this is 15 degrees, and this over here is 30 degrees. So where does this leave us? Well, we basically are asked for the ratio between FGI and EIH. So clearly these two triangles have to have something in common, and hopefully you can see now that both of them have 15 degrees as one of the angles, and both of them have a right angle as the other. Therefore this is 75 degrees because angles in a triangle add up, and so is this. So now all three angles are the same, therefore they have to be similar, right? So let's just redraw both of these like this. This over here is F, G, I, and this is E, I, H. I, E, and H. Both of these have the same angles, which are 75 degrees, 15 degrees, and they are both right angles. So if we just work out what the ratio of any side length is, the ratio of the side lengths, we'll be able to work out the area ratio. Because remember, if there are two similar shapes and you know the side length ratio, if you just square that, you get the area ratio. We'll come to that a bit later. But now, if we just rub out all of this information, just to make it a bit neater. Now, we know that both of these triangles share this common hypotenuse. So now, if we just label this as x, okay? In the triangle EGH, let's just work with this for now. EGH. If this is x, then EH squared plus EG squared equals x squared. EG equals EH since it's a right angle isosceles triangle. Therefore EH squared times 2 equals x squared. Okay? Therefore, if we just rearrange this for EH squared equals x squared divided by 2, therefore EH equals x divided by root 2. So this is basically what EH is. Now, if we use a similar thing to work out what FG is, we'll be able to know two of the side lengths within our triangles. So let's just draw in this triangle. Sorry, I don't know what that line was, but if we draw it like this, 90 degrees, 60 degrees, and 30 degrees. This is x. So now if we just go back to our diagram, we're trying to work out what FG is based on this triangle over here, okay? So let's just label this as B, okay? F, G, and I. Therefore, now we'll need to apply some trigonometry. So we know that x is the hypotenuse, therefore sine 30 remember sine 30 is opposite by hypotenuse, so it's b divided by x. Therefore, whatever sine 30 is, that is the ratio of b to x, okay? We know that sine 30 is a half, therefore the ratio of b to x is just a half. So if we just rearrange, x equals 2b. Therefore, b equals x divided by 2. And if we go back to our diagram, FG was b, okay? So now, let's go back to our original diagrams. Sorry, that should be F. So now, we know that this is b, which we just worked out to be x divided by 2. X divided by 2. And we also know that EI, which is this side of EH, sorry, which is this side over here, that is basically x divided by root 2, as we can see over here. So x divided by root 2. One of these is x divided by 2, one of these is x divided by root 2. So therefore, the ratio of the side lengths is this. Now, let me just label this as side length ratio. It's x divided by 2 to x divided by root 2. So that's basically just a half to 1 over root 2, okay? Now, if we just consider these two squares, we'll just think of this. So one square has side length of 2, and one square has a side length of root 2. Therefore, the area of this square is 4, and the area of this square is 2. So the ratio of the side lengths is 2 to root 2, but the ratio of the areas is going to be 2 squared to root 2 squared. So in this case, it's 4 to 2. So that was just like a way to think about how we can relate side length ratios to area ratios. So then, therefore, ratio of a half to ratio of root 2 is basically, if that's the side length, then this is the area. 1 divided by root 2 all squared, right? Which is basically just a quarter divided by a half. So therefore, the ratio is just 2 to 1. Okay? So yeah. That's basically our final answer. Sorry, this should actually be 1 to 2, but it's the same thing. And that gives us an answer of D, 1 to 2. So let's just go back to our flowchart real quick. So here's our flowchart, and let's just map of how exactly we cracked this problem, which isn't a very easy problem at first sight. We basically found that both of these were similar, and then we identified that if we just worked out the ratio of the side lengths, we'd be able to work out the ratio of the areas. We applied some trigonometry and worked out that sine 30 was the ratio between GH and FG. We found FG and EH, and we used the area scale factor to side length scale factor kind of concept, and yeah, that's how we solved the question. I hope you enjoyed looking at this question. If you did, hopefully you learned something, and please be sure to leave a like and subscribe. That would be very much appreciated, and I hope to see you next time. Thank you. Bye.